Okay, now recording. All right, so today's the last day before our break. So that's nice, I guess. Go back to sharing the screen if possible. So game plan is this. So we are over here doing 8.4. I'm not sure I'll finish 8.4. It's okay if I don't. And then I'll go ahead and give you a quiz. I want to make sure I have enough time for you to do the quiz. It's graphing these things. They take some time sometimes to figure out, all the stuff that I did yesterday. So I'll give you a cosine and a sine one, figure out what's the amplitude, what's the period. Okay. Is there a horizontal shift? Is there a vertical shift? What's the range? How high and how low is it? What's the midline, right? How far is one period go from here to here? Okay. Normally we start at 0, but because of the horizontal shift, maybe you have to move somewhere else. Okay, so we're doing that. Okay, and heads up for the next exam is a week from Thursday, it'll be the 8th after we come back from break. Okay, we still have 8.4 and 8.5. That should be no problem there. Okay, I can pretty much declare we're not going to have the next exam on the 15th. So that'll be pushed back. We got plenty of extra days. Okay, I've barely used any of my buffer days yet. Okay, so if I don't get that far with 8.4 today, that's okay. I can still do 8.4, 8.5 when we come back from the spring break. Okay. All right. In fact, 8.4 kind of reinforces a little bit of the stuff that we did yesterday, so it'll help you for the quiz that I give you. Only the numbers tend to come out much worse. Okay. All right. So let me get started with 8.4. Maybe do a couple of problems, and then go from there. Okay. The topic is something called simple harmonic motion. There are real life situations which behave like trig functions. Like this thing, the spring, it bounces up and down, up and down. It's called simple harmonic motion. There's a maximum, there's a minimum, there's a midline. It tends to bounce back and forth between certain points. Okay, so if you measure the height as time goes by, it looks like a sine wave, sinusoidal. Okay, in fact, it looks like they even came up with the equation. S is -2 cosine pi t over 3 or something like that. Okay. Right. We've had terminology like the period. Okay, and there's the formula 2 pi over b. One new word is something called the frequency. Frequency is just a reciprocal of the period, 1 divided by the period. It's how many cycles you have per unit time. So frequency is just a reciprocal of the period, cycles per second. Okay. They have amplitude, as you can see there also. We've already talked about amplitude before. Right now, there are only, quote unquote, 5 problems, but you can see how long any one problem is. Look at number 1, A, B, C, D, E. Number 2 has A, B, C, D, E, and 3 looks like A, B, C, D, E, F, G, H. Okay, so even though there's only 5 problems, each problem has part A, B, C, D, and so on. So 4 is A, B, C, D, E, F, G. Okay, so my goal right now, at least, is to show you the even ones because you don't have the even answers in the back of the book. So I was going to try to show you 2 and 4, and maybe that's all, but if I have time, I'll go ahead and do another one. Okay, so let's jump to number 2. Okay, so assume that a simple harmonic motion described by the equation S equals -6 cosine pi t over 6, S is in centimeters, T is in seconds. Okay, so let me put that down. Oh yeah, let me do the usual of showing you the book in case you're one of the students that is never getting the book. So you can read everything there. Whoops, come back over here. And more there, and more there. And problem 4. Hopefully that's somewhat readable. And 5. 5 is actually relatively short. It's quote unquote only ABC. Okay. All right, so let me get you started on number 2. So 8.4. Number 2. And it's on page 579. All right, so the equation that they give me is S equals -6 cosine pi t over 6, or pi over 6t. S is in centimeters. T is in seconds. All right, first they give me the super long table to fill in. Okay, now they write it horizontally. It's better for me to go vertically. Okay, so I'm going to write it vertically. It's the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and I may want to refer back to my unit circle, 30 degrees, 60 degrees, and so on. Right, so this is pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, and so on. Okay, if I plug in 1, I want the cosine of pi over 6. It's radical 3 over 2. It's not a half. It's either going to be half of radical 3 over 2. So it's -6 times radical 3 over 2, which is -3 radical 3. It's roughly -5 if you punch it in a calculator. Plug in 2. 2 pi over 6 is pi over 3. Cosine of pi over 3 is a half. So -3. Plug in 3. Cosine of 3 pi over 6, that's pi over 2. X coordinate is 0. 4 pi over 6, 2 pi over 3. X coordinate is -1/2. So -6 times -1/2 is +3. 5 pi over 6. That's going to be negative radical 3 over 2. So 3 radical 3, approximately 5. Plug in 6. Cosine of pi is -1. So -6 times -1 is 6. And it's just going to cycle back. Okay, so 5, 3, 0, -3, -5. And if I plug in 12, taking the cosine of 0, which is 1, so -6. Okay, and that looks like one entire period. All right, so part A says fill in the table. Part B, amplitude. This is the A. This is like the B. It looks like there is no C or D. Amplitude is the absolute value of -6. 6. Formula for the period is 2 pi divided by B. 2 pi divided by pi over 6. Okay, if you divide by a fraction, you multiply by the reciprocal. 6 over pi, cancel, cancel, 12. So the period is 12. They had me take the table, go all the way out to 12. So that's perfect. All right, so it says amplitude period frequency is the reciprocal of the period, so 1/12 cycle per second. Sketch the graph between 0 and 24. So between 0 and 24, that would be considered 1 day. That's 2 periods. Okay, so we go from 6 to -6. So 1 period is from 0 to 12. They told me to go out to 24, so I'm going to do 2 periods. Okay, and the range is -6 to +6. Okay, so I'll try to squeeze it in here and just change the scale a little bit. So they told me to go out to 24, say 24 hours a day. So that's 12, what, 18, 6, 3, 6, 9, 12, 15, 18, 21. And rather than counting by ones, how about I'll go 2, 4, 6, 2, 4, 6, -6. All right, this is cosine, which normally starts at max, but the negative means I'm starting at the minimum. So minimum, after 1 period, minimum. Okay. Midline, maximum, midline, minimum. Now just copy and paste that over to here. So maximum, minimum, 0, 0. Okay, you said, what about the 5 and the -5? They're there. I'm just not highlighting them, but they're there somewhere. So there's 2 periods. Okay, C. Use your graph to determine the times in this interval at which the mass is farthest from the equilibrium position. Farthest away means either 6 or -6, right? So that would be at 0, 6, 12, 18, and 24, right? T equals 0, 6, 12, 18, and 24 hours. Okay, or if this is considered midnight, it'd be midnight, 6 a.m., 12 noon, 6 p.m., and then back to midnight. Okay. When during this interval of time between 0 and 24 is the mass passing through the origin? Okay. In other words, when is the height 0? 3, 9, 15, and 21. Okay. So T equals 3, 9, 15, 21 hours. Okay. I guess I have to translate. Okay, let me translate this as time. Okay, so this would be 12 midnight, 6 a.m., 12 noon, and 6 p.m. And then back to 12 midnight, but we already said that. Okay, so this would be 3 a.m., 9 a.m. 15 hours is 3 p.m., right? 3 p.m. And 2100 hours is 9 p.m. Okay, so that's it for that one. And finally, E, when during the time interval is the mass moving to the left? And the mass is moving to the left when the x-coordinate is decreasing. Use the graph to see when S is decreasing. So when is the graph decreasing? When's the graph going down? So between 6 and 12 and between 6 and 12 p.m. Okay, so from 6 a.m. to 12 noon and 6 p.m. to 12 midnight. Okay, then that means the mass is moving to the left. Mass moving to the left. Okay, so that's everything for problem 2. I'm done with problem 2. Okay, and I'll raise it up again for focusing purposes so you can see what I did, answered all the questions that were there. Okay, so in case you can't see it, I raise it up for focusing. Okay, all right, number 4. What does it say? All right, so you have simple harmonic motion described by S equals 4 cosine blah, 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 blah. S is in feet, T is in seconds. Equilibrium of the position is S equals 0. Okay, so let me write that down. S is equal to 4 cosine 2t over 3. All right, so to answer all these questions, let me just analyze it. Amplitude is 4. Period is 2 pi divided by b. 2 pi divided by 2/3. If you divide by 2/3, you multiply by 3/2. So 2 pi times 3 over 2 and cancel the 2's. 3 pi, it's 1 period. All right, so part A, amplitude we got, period we got. Frequency is 1 over the period, 1 over 3 pi. All right, sketch from 0 to 6 pi. Period is 3 pi. So once again, that's 2 periods. Three pi, 6 pi, 2 periods. Cut that into 4. Cut that into 4. So 3 pi divided by 4. 3 pi over 4. 6 pi over 4. 9 pi over 4. 12 pi over 4. 15 pi over 4. I keep adding 3 pi over 4. 18 pi over 4. 18 pi over 4, 21 pi over 4, and 24 pi over 4. Okay, so it works. Okay. For the quiz today and homework and exams, you should show me all these in between points also. Okay, amplitude is 4. There's no vertical adjustment, so 1, 2, 3, 4, 1, 2, 3, 4. So the range is from -4 to 4. And 1 period goes from 0 to 3 pi. So 1 period is after here. We're doing a cosine. A is positive. So cosine starts at the maximum, 4, midline, 0, minimum -4, 3/4 of the way back to 0, and then maximum 1 period. Copy and paste that over here. There we go. Okay. B, when is the mass moving upward? That means the S coordinate is increasing. So when is the graph increasing? Increasing, oh, it'll be increasing, going up from here to here. Pretend it's a roller coaster. When are you going up? Well, from here to here, and from here to here. So where's here to here? 3π/2 to 3π. Union here to here, 9π/2 to 6π. That's when the graph is going up. So increasing. Okay, for my calculus students, I like to write increasing like that. That's very suggestive. As I move from left to right, it goes that way. Decreasing, I would have an arrow down. In fact, C, it asks for decreasing. C, when is it decreasing? When are we going down the roller coaster? Here and here, right? Decreasing in calculus, I would write it like that. So between 0 and 3π/2, 0, 3π/2, union, where else am I going down the roller coaster? Between 3π and 9π/2. Okay. D. For this harmonic motion, it can be shown by calculus that the velocity is given by -8/3 sine of 2π/3, where t is in seconds and v is in feet per second. Graph the velocity function over the interval from 0 to 6π. Okay, so we're doing a brand new graph. So let me get that. The velocity function, you write it down again, -8/3 sine 2π/3. Okay, so same thing. Amplitude is the absolute value of this 8/3. Period's the same. It's still 2t/3, so I just copy the period over here, which was 3π. That doesn't change. So the range is -8/3 to 8/3. That's 2 2/3, roughly. Okay. So graph that. We are practicing for today's quiz, except for we haven't done any horizontal or vertical shifts, but you should already be experts at horizontal and vertical shifts, right? We did that a long time ago, right? Move left, right, up, down, as the case may be. And once again, it says to go out to 6π. Six pi, 3π, 2 periods. So I can just copy these numbers. 3π/2, 9π/2. Then chop each of these in half. 3π/4, 9π/4. 3 pi over 4, 9 pi over 4, 15 pi over 4, 21 pi over 4, 15 pi over 4, 21 pi over 4. 8/3 is 2 2/3. So 1, 2, 3, 1, 2, 3. And maybe I'll just make a little mark here to indicate. Okay, that's supposed to be 2 2/3 roughly. All right, we're doing a sine function. There's a negative. So negative means starts at the midline. If A is positive, I start up, but it's negative, so I start down. So midline, minimum, midline, maximum, midline. Okay. And copy and paste one more time. So there, 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 there. So there we go. That's D. E. Use the graph from part D to find the times during the interval when the velocity is 0. When is the velocity 0? At these times, where is the mass? Okay, so when is the velocity 0? Well, here, 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 right? So 0, 3 pi over 2, 3 pi, 9 pi over 2, 6 pi. Now it says, where is the mass? At these times. So I plug in, S of 0 is 4 cosine of 0, which is 4. S of 3 pi over 2, plug in 3 pi over 2 here. 3 and 2 cancels out. I'll be taking 4 cosine of pi, which is -4. S of 3 pi, plug in 3 pi, I'll be taking 4 cosine 2 pi, which is back to 4. It's just going to keep going like that. S of 9 pi over 2, plug in 9 pi over 2. 2's cancel out. I'll be taking 4 cosine of 3 pi. Cosine of 3 pi is -1, so -4. And finally, S of 6 pi multiplied by 6 pi, I'll be taking 4 cosine of 4 pi, which is 4. In other words, at the extremes, the maximum minimum values, the velocity is 0. Okay, and this does make sense. Okay, imagine you have a spring that bounces up and down, up and down, up and down. Maximum is 4, minimum is -4. Well, right at 4, the velocity is 0 because it's not moving just for an instant and then it goes back the other direction. Right. Likewise, when you're at the minimum at -4, it doesn't go down anymore. It ever so slightly for an instant stops and then it goes back up. Okay. So in other words, at extreme values of S, extreme values of X, that's the max or the min, velocity is 0. Right. General principle of physics. Okay. If we toss an object in the air, you throw something up in the air, it goes like this. Okay, it's going up, right at the top, just for a split second, it's not moving, right? And then it starts to come back down, right? So right when something turns direction, the velocity is 0. Okay, so that's what's happening for E. Okay, F. Use your graph of the velocity function to find the times where the velocity is maximum. Where is the mass at these times? Okay, so where is F? Where's the velocity a maximum? Velocity a maximum. So here, 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 and here, right? So 9 pi over 4, 21 pi over 4. Maximum velocity. 9 pi over 4, 21 pi over 4. And the large is negative also. So 3 pi over 4, 15 pi over 4. Maximum velocity. So the velocity is positive 4 and negative 4 here and here. Okay. And then it says, where is the mass at these times? Look at this function. 9 pi over 4, 21 pi over 4, 3 pi over 4, 15 pi over 4. It's at 0. Okay. Mass at 0 for these times. So that means when you have a spring, right? Spring bouncing up and down, okay? At the maximum and the minimum, velocity is 0. Okay, exactly halfway, right at the equilibrium point, that's where you have the maximum velocity. It's traveling the fastest. Imagine a spring going up and down, up and down, up and down. Okay, when it's coming through right here, it's the fastest. And also when it's coming up like this, it's the fastest. Okay, that's what they're saying. Okay, imagine bouncing up and down. Right at the top, velocity is 0. Right at the bottom, velocity is 0. Right when you reach that midline, the velocity is the fastest, speeding up, and then it starts to slow down. Okay. And G, well, we sort of already answered that. When's the velocity at minimum? What's the mass at those times? It's also 0. Okay. By minimum, I think they're also meaning, the bottom. I think that's what they meant by that. But for velocity, technically velocity could be, either positive or negative. Okay, so I've sort of already answered that question there. So I was looking at the absolute value actually. So this is actually F and G. So I'm finished with that. Okay. All right, I'm done with 2 and 4, folks. It's only 11:45, so maybe I'll be able to sneak in one more, and then we can go straight to the quiz. How's that? Okay. All right, so the homework was 1 through 5. I've already done 2 and 4, but you don't have answers in the back to. It's only 11:45, so maybe I will sneak in, let's say 5, and then I'll stop there. So I'll let you do 1 and 3 on your own. So if everything's according to plan, then I would be able to mark off 8.4 completely and not save any of it for next time. Okay, so there would be 5 problems. I would have done 3 of them, over half. I did 2, I did 4, I'm about to do 5. Okay, and so, yeah, it looks like we will be on schedule. So Monday when we come back from spring break, we'll go straight to 8.5. And the exam will cover chapters 7 and 8. Okay, so chapters 7 and 8, I can mark this off right here. Okay. All right, so we should be fine from when we come back from spring break. Okay, and then after that, we have a test for 9 and 10, and 11, 12, and 13, sort of. We're not doing all of 13. Then we're done with the class. Okay, so let me do 5, and then we're done for the day. All right, so voltage in an electrical outlet, they behave under simple harmonic motion with a sine or cosine curve. So 170 cosine blah, 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 blah. Okay, so let me write that down. Voltage is 170 cosine 120 pi t. V is in volts. T is in seconds. All right, amplitude, period, frequency. Amplitude is 170. Period, this is the B. 2 pi divided by B, 2 pi divided by 120 pi, pi's cancel out. So it's 1 over 60. Frequency is the reciprocal, so 60 per second. Sometimes we say 60 cycles per second. Okay, so we have 60 cycles within 1 second. All right, B. Graph the function for 2 complete cycles beginning at t equals 0. Okay, 2 cycles means 2 periods. Okay, cycle is the same thing as a period. So 1 over 60, it's not very much. One over 60. Double that, 2 over 60 reduces to 1 over 30. Let's divide that by 4. So 1/60th divided by 4 is 1 over 240. 2 over 240. 3 over 240. 4 over 240. 5 over 240. 6 over 240. In general, you should reduce. 7 over 240. 8 over 240. Okay, we're not going to draw this to scale. I'll just quickly say this is 170, negative 170, right? All right, 1 period is out to here. Cosine, no negative, positive. So cosine starts at max, 170. Midline, min, midline, max. They want 2 cycles, 2 periods, so just copy and paste. Midline, minimum, midline, max. So there we go. That was B. C. For what values of T is the voltage maximum? Maximum voltage. Maximum means the highest. That's here and here and here. So T equals 0, 1/60th, and 1/30th. T equals 0, 1/60th, 1/30th second. And there we go. Let me do my focus thing and then I'm done, folks. So I'm just about to give you the quiz. We don't need to break. We'll just go straight to the quiz, and the break is you can leave and then have a nice spring break, right? Okay, so if you have any questions, go ahead and put it in the chat right now while I do my focusing thing. Okay, and by the time I finish this, if I don't see anything in the chat, we'll go straight to the quiz, and then everybody have a nice spring break. Okay, and I'm not sure if I did it on this side already, but I'll do it again anyway, just in case. Besides, that gives you more time to ask questions if you have any. There's that. And that. And that. Okay, so that'll do it for today. I don't see any questions. I don't see the chat, so we'll go straight to the quiz. Okay, so give you the quiz. It'd be like a regular quiz, you know, put you in groups of 4 or 5. Star will go around and see if anybody needs help. And so we're here. Next week we're off. Everybody have a good break. We're on schedule. So Monday, April the 5th, 8.5. The exam would be that Thursday, the 8th. I should finish over here. I'll probably get started with some of chapter 9 also. Okay, we will not have exam 5 on that Thursday. I'm almost sure we'll push the schedule back a little bit there. Okay. All right, so get your cell phones out for take a picture or do a screenshot. Okay, here we go. Okay, give the amplitude, period, and horizontal vertical shifts of the graph and sketch one period of the function. And in your sketch, I need to see, you know, where do you start? Where do you end? 1/4 mark, halfway, 3/4, just like I did in class the other day. Okay, so number 1, y equals 3 sine of 2 parentheses x minus pi over 4 plus 1. Number 2, y equals -2 cosine of 3 parentheses x plus pi over 6 minus 2. Okay, so questions that you want to ask yourself is, what is the amplitude? What is the period? Okay, where does one period start and end? Is there a horizontal shift? There is. Is there a vertical shift? There is. As you might guess, I have one going every direction. Okay, there's one that's going left, one that's going right, one that's going up, one that's going down. You know, if I'm going to test you for all of that, makes sense. Please notice that this one has a negative, right? That one's a positive amplitude, that one's a negative amplitude. So you think about all that. Okay, also, when I set you in your breakout groups, I believe I can now set it so that you can screen share. So if some individual wants to do a screen share, you might be able to do that. Okay, so I'll set up your groups in that fashion. Okay, so again, number 1, I'm going to make this disappear in a few seconds. Number 1, y is 3 sine of 2 parentheses x minus pi over 4 plus 1. This is A, this is B, C, and D, right? Number 2, y equals -2, that's A, cosine 3, that's the B, x plus pi over 6, so the C is -pi over 6, and the D is -2. Okay, I'm going to assume everybody has it now, so I'll make this disappear. Go ahead and get started. I'll set up your breakout rooms. Put your first and last name and first and last name of everybody in your group, as always. Okay, and when you're done, submit it, and everybody have a good break. Okay, I believe I've given share screen possibilities, so you can now share the screen as you need to. Go ahead and get started. I'll set up your breakout rooms. Okay, and Star may be going from room to room as necessary. I don't see Mackenzie, so Star, I'll put you in a room, and when you're done, you can come out like before and choose some other.